I want to make a few additional comments about unit vectors. Unit vectors show up a lot, and they're often something that people are not terribly familiar with before seeing mechanics at the university level. So we'll take a few minutes to just talk about what we actually mean by unit vectors. Definitionally, actually, what we mean is sort of embedded in the term. Unit means length of one, because one is the unit, and of course, vector means it's a vector which has a length of 1. So a few things to note about unit vectors. One is that, of course, they have a length of 1. The other is that they do not have any dimensions. They are unitless, which is, of course, a little confusing since they're called unit vectors. And they typically are defined as pointing in a particular direction with respect to the coordinate system. And often you'll find they are pointing in a direction in which one of the coordinates increases. So, for example, if I had this coordinate system here and I said, there was this A and B, I could define a unit vector A hat that points in the direction of increasing A, and I could define a second unit vector B hat that points in the direction of increasing B. And if I had some vector that looked like this, say capital B, and I resolve that into its components in this coordinate system, I might have this, maybe this is 5 long in the A direction and 1 in the B direction, so I had capital B is 5 times A hat plus 1 times B hat. Now, it's fairly common to also use unit vectors that refer to the direction of an individual vector. We actually saw this a little while ago when we talked about the vector A, right? And we said, okay, this vector A has a magnitude. Okay, that's the magnitude of A is the length of the vector, right? And it also had a direction, which we said was A hat. So you could equivalently write the vector A vector as being the magnitude of A times the unit vector A hat, which of course gives you a little bit of insight into how you might actually go about finding A hat. A hat could be written simply as the vector divided by the magnitude of the vector. So as an example of that, let's figure out what B hat is. So what is capital B hat with respect to little a hat, little b hat? Well, we know that capital B vector is 5 times a hat plus 1 times b hat. We can figure out what the magnitude of the vector b is by taking the square of both components and then summing them, taking the square root. So 5 squared is 25, 1 squared is 1, so radical 26 is the magnitude of b, and so that means the vector b hat is going to be 5 times a hat plus 1 times little b hat divided by radical 26, or 5 over radical 26 in little a hat direction plus 1 over radical 26 in little b hat direction.